Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have a function natural log of x minus x, and we have to find all relative extrema to the graph of this function, if there are any. So, how do we compute relative extrema of a function? We have to compute its first derivative and then see where the derivative is 0 or undefined. So, let's start by computing y prime. And y prime is ddx of the expression of the function ln of x minus x. Okay, so let's compute the derivative. What is the derivative of natural log of x? It's just 1 over x. And derivative of x is 1. So that's y prime. Now, we have to figure out where is y prime equal to 0 or undefined. The best way to do it is if we combine these two terms into one fraction. So we will have a numerator and a denominator, and then we can figure out where it's 0 or not. So let's do that. Just simplify it, and we will do a common denominator addition. So this 1, you can, since we have a denominator of x, we can rewrite this 1 as x over x, and then we will have a common denominator, and in the numerator we have just the difference of the two numerators, 1 minus x. So this is the expression for y prime. Okay, so to figure out relative extrema, we need to find critical points. So where is y prime 0? Y prime is 0 if the numerator of this expression is 0. If 1 minus x is 0. And that means x is equal to 1. So that is a possible extrema. What about the other expression in the denominator? Because it can happen that the function will have an extrema and the derivative is not defined. So notice what happens if the denominator is 0. So if x is 0, then the derivative is not defined, which is fine. But let's go back and look at our function. What happens there? See, if you plug in 0, you get natural log of 0. And natural log of 0 is not defined at all. So at x equals 0, function is not defined. So function is not defined, which means 0 is not even in the domain of the function. So there is no question of figuring out extrema at this value. So we just discard this x equals 0 and we only consider x equals 1. So that is a point where we will have an extrema. Question is, what kind of extrema? Maxima or minima? For that, we need to compute the second derivative. So let's see what happens at x equals 1. Let's figure out the second derivative of this function. First derivative is right here, or we can actually use a simpler expression for first derivative instead of this one. So let's say y double prime is the derivative of this expression here, 1 over x minus 1. Okay, so notice that 1 over x can be rewritten as x to the power negative 1, because if you do that, then we can just use a power rule. And this is negative 1. So apply power rule. So derivative of x to the negative 1 is negative 1 x to the negative 2. And 1 is a constant, so its derivative is just 0. And therefore we have the second derivative is, now rewrite this one more time using the exponent property to say this is negative 1 over x squared. And the 0 just goes away. So this is our second derivative. And we have to figure out what is happening at x equals 1. So what is the second derivative at x equals 1? Well, that is nothing but 1 over 1 square with a negative sign. So this is negative 1. So second derivative is negative at x equals 1. Now, do you remember what that means? If the second derivative is negative, that means second derivative determines the concavity of the graph. So negative means the graph will be concave down. And if the graph is concave down, that point will give you a maxima. So the second derivative just gives us whether this extrema will be a max or a mean. And we just proved that it will be a maximum point. So we can conclude from all of this that at x equals 1, the function will have a relative maxima. All right. So to finish this problem, we will have to use a graphing utility to verify this result. So let's pick a graphing utility that you have, and let's graph our original function. So y equals natural log of x minus x, and graph it. So you see that the graph lies below x-axis. To see it better, let's go to window and change the x values from -1 to 10 and say y from -10 to 5, because we only need to see the right hand side of y-axis and below x-axis. And then graph it again, and you see that there is a maxima, and then the function is decreasing from that point onward. So let's go to trace and see if we got a correct value or not. So plug in x equals 1 and enter, and it looks like in the graph that it is giving us the maximum value. To be sure, just move that x value a little bit to the right or to the left, and you will see that the y values are less than the y value for x equals 1, which is -1. So that also proves that at x equals 1, the graph will have a maxima. And so that is our answer, a maxima at x equals 1 to the graph of this function. Thank you.